novel control methods, and many more. So I would like to request Sir to share his knowledge with the participants. Sir, please.
Thank you. Thank you,
Thank you, sir.
Anuraka, for your nice introduction.
Thank you so much.
First of all, I extend heartfelt welcome to all the participants and very good morning and wish you a very happy new year to all of you, all the organizers as well as the participants. Uh, this is a pride privilege for me to be here in this forum. I will share particularly on the topic that is energy management and control. Let me to share my PPT. Is it visible?
Yes, sir.
Okay. Thank you. Particularly, my presentation will be on the smart microgrid system with sustainable energy. Focus will be on the energy management and control aspects. And in my presentation, I have divided it to two subsections. One is the introduction to microgrid and smart grid systems. And next part will be the control and power management. Though all of us know, because we should not go into the depth, my presentation will not be so much mathematical, all those things. I will go very informative kind of thing. As we move towards an increasing electric world, more energy will be produced by decentralized renewable sources. That all of us know that we are mainly focusing on the solar, wind, and slowly when we will talk about the solar and wind, that is you can say that it is not fixed power generation sources. That's why you need the batteries, electric vehicles, and other energy storage devices. And slowly, the centralized power generation will be moving towards the decentralized power generations. What we mean by the centralized power station? That means you are generating a huge power at a particular place and you are transmitting the power to the load side. But with the help of these renewable energy sources and storage devices, you can generate at your premises also or at your campus also. That means the power generation will be distributed and power can be generated at the load site itself. You need not to transmit the power from the distance place of the generating station to the load side. And main idea is how to reduce the greenhouse gas impact on the environment. And in that way, the massive penetration of renewable sources are gaining importance day by day. The existing distribution networks are designed and operated in radial configuration with unidirectional power flow from centralized power plant to the customer side. That is the conventional power system. But when you will integrate the massive DG sets into the distribution network, then the reverse power flow occurs. It is not that only from the generating station to the load, there will be a reverse power flow in the distribution network. This creates complexity in operation and control of existing distribution networks and offers many technical challenges for interconnection of DGs. As we told that power generation from renewable energy source and energy storage system is one of the integral part of the microgrid or renewable energy systems, because the solar and wind depends on the environmental conditions. Depending on the environmental conditions, you will get the power generation. And to meet the particular load demand, we should have the energy storage system so that it can support the deficit of power. There are various renewable energy sources that all of us know. The most important benefit of the renewable energy source is the fact that it is non-polluting in nature. Unlike the present sources such as coal and fossil fuels, renewable energy sources are inexhaustible. This means they can be used repeatedly because it is available in the nature. As we all know that the burning of fossil fuels emits harmful gases in the atmosphere, or you can say that may harm the environment by various factors such as global warming, greenhouse effect, and above all is the pollution. Renewable energy resources are clean sources of energy that have lower environmental impact than conventional energy resources. These are the very basic things all of us know. Coming to the statistical data, at present, it will see still we are depending on the coal around 56%. And if we'll see the renewable source and nuclear, hydro, all those things, that is altogether coming less than 50%. And if you'll see the renewable sources, major source is the wind and solar. That means the renewable energy, what we are using at present, that is the wind and solar, that may take the dominating power source, and it will meet our load demand in future. That's why we should be very much focused on these two sources with other auxiliary sources, you can say. There are different types of the energy storage systems like the battery, flywheels, supercapacitors. And all these energy storage systems have the same basic components or the features like the interface with the power system by means of the power converters, and there will be a charge and discharge control unit And definitely the energy storage medium will be there. As I told you, there are different types of the energy storage systems. Like one more is superconducting magnetic energy storage, that is SMES. That is also used for a very critical applications, but its cost limits its use. It is a huge cost, but in a particular industry where the shutdown.
Excuse me,
Yes,
sir.
yes,
Uh,
yes.
sir, sorry to interrupt, sir. Actually, the slide is not visible right over here.
When? From the beginning,
No, sir, it's just right now.
just right now.
It's
How?
sir,
It's not visible. It's
kindly
not
share it
visible.
again.
No, sir, not
No,
visible.
sir. The sharing
How?
is, I think.
I
Just
have not done
typing is there.
anything. Okay. I have to. Okay. I have to share again, I think.
Sir.
Yes, sir.
This part is not also coming.
No, sir.
No,
Huh?
sir, I think.
Yes, sir.
Now it's coming, right?
Yes, sir. Visible, sir.
Yes, sir, now it has been started.
Now it's okay.
Sir, actually, you put it as stop sharing again, so that's it.
Now it is okay, no?
No, sir.
No, sir,
No.
actually, somehow it has been
Oh,
clicked with stop sharing.
okay. So there is a skip or stop, something is there, I think.
Oh, yes, sir. Yes, sir. Visible, sir. No.
Okay.
Clearly visible.
Visible, I hope.
Yes, yes, sir. Yes.
Yeah, we are talking about this statistical data of renewable energy source. Particularly, we are depending on the PV as well as the wind, which produces the major renewable energy source power. When we talk about the renewable energy sources from solar and PV, solar and wind, definitely you have to go for the energy storage systems. There are different types of energy storage systems, like the battery superconducting magnetic energy storage, that is SMES, which is mainly used in the very high standard industry where the means you can say that shutdown is not permitted at all. For example, semiconductor fabrication, where you can go for the SMES as the storage device, but that is very costly. And generally, we use in case of microgrid systems, particularly the battery, supercapacitor, fuel cell, all those things we used as the storage. The use of batteries as a system to interchange energy with the grid is well known. There are several types of the batteries that also, like lead acid, lithium, and nickel. And depending on this cost, you have to compromise with the cost or size like that. Yeah, now, though, we are focusing mainly on the lithium ion batteries. Although the discharge rate is limited by the chemical reactions and the type of battery, they act as a constant voltage source in the power systems. There are different technologies or different algorithms used how to make the optimal sizing of the batteries cells for particular applications. That also you have to think of when you are designing a microgrid system, considering a particular kilowatt range. You have to design or the proper sizing of the batteries, supercapacitors, all those things you have to take into account. There are different parameters because you cannot purchase a battery as you like. You have to think depending on your application, which of the parameters are important for you. And there are 7 important parameters like the longevity, safety, power density, cost, energy density, energy capacity, and voltage per cell. Depending on that, you have to select your battery. And now the main focus is on plug-in electric vehicle, which will be used as a energy storage. And in the coming years, we'll find this will take the dominant this will take the dominant role compared to the battery, because this will act as a energy storage. No need of going for the again separate battery source for the microgrid system. Coming to the electric vehicles, environmental issues and greenhouse gas emissions, concerns of the generating electricity by burning the fossil fuel, and recent increase in energy price. The number of plug-in electric vehicles has been rising in recent years and will continue to grow. You'll find the many research articles means how you will coordinate the charging and discharging station of the electric vehicles, and at the same time you have to improve the grid resilience also, because immediately if the thousands of vehicle will come into the charging station, then the grid stability or the you can say that your voltage may not be maintained at that instant. Modern electric power system at the same time is gradually evolving into smarter grid with two-way flow of information and electricity between the demand and the supply. That means in case of modern power system, we will not be the passive consumers only. We will become the active consumers. That means we can also have the option to sell and purchase the power depending upon the need. Battery energy storage system is considered to be an integral part and one of the most promising ideas to achieve this concept. In particular applications, supercapacitors plays an important role because immediately it can pick up and meet the load demand. In some particular application, only the battery may not help you. So that you can go for the combination of a battery and supercapacitor. Because if there is a sudden load change, depending on the time constant, you will find the supercapacitor will come into the operation faster than the battery. Here the question arises, can the supercapacitor replace the batteries? As I told you, means in particular applications you need the combination of battery and supercapacitor. And batteries can provide the power for sufficient time, but which is not possible from the supercapacitor. It has one advantage as well as disadvantage. What are the differences between the supercapacitor and batteries? There are four main differences between the supercapacitors and batteries: energy density, power density, lifetime, and cost. Very important terminology like energy density and power density. Two things are opposite to each other. Energy density refers to the amount of charge a technology can hold. Capacitors have the lowest energy density, whereas the supercapacitors have the greater energy density compared to the capacitor technology. But if we compare with the batteries, it has the lesser energy density. That means the battery has the more energy density and it stores the charge electrically. Which one? The supercapacitors hold the charge electrically and batteries store the charge chemically. Chemical reactions have the capability to store much more energy than the electrical storage, which is what contributes to the battery being used more often in applications that requires higher energy or higher power. But the power density is a different way. Power density refers to the amount of time it takes a technology to charge and discharge energy. Batteries have the disadvantage in this characteristic due to the chemical reactions that take place to store and release energy. It takes enough time to store the energy and release the energy. Whereas the supercapacitor take very less time and go for the faster charging and discharging. That's why the if we'll talk about the power density, supercapacitors have the better choice compared to the battery. Here, if you see, we have given one, we have taken from literature that different storage devices, how the power density and energy density. If you see, the fuel cell has the highest energy density compared to the other storage systems. If we'll talk about the lifetime and cost, lifetime chemical reactions are the limiting factors for the lifetime of the battery. That means the supercapacitors have the better lifetime compared to the batteries. But when you will go for the lifetime, you have to think again the cost. In case of supercapacitor, cost is more. If you go for the same rating of the battery and supercapacitor, you have to pay more for the supercapacitors. This is one energy storage system, that is the flywheel energy storage system, which works by accelerating a rotor to a very high speed and maintaining the energy in the system as rotational energy. When energy is extracted from the system, the flywheel rotational speed is reduced as a consequence of the principle of conservation of energy. Adding energy to the system correspondingly results in an increase in the speed of the flywheel. And nowadays you will find the fuel cell is mainly used for the energy storage system, or you can say it is a generating source also. The fuel cell is an electric power generating system that converts the chemical energy of hydrogen, etc., into electric energy using the principle of electrochemical generation. That means it is a reliable choice. Fuel cell can be used as a reliable source. It does not depend on the charging or discharging as like the battery. If your fuel is available, like hydrogen is available, it can convert to electricity and you will get the power. This is a more reliable source, you can say. And this is used in combination with the PV as well as the wind, so that the system will be more reliable. Depending on the number of fuel stacks, you can increase or decrease of the capacity. What is the major difference between the battery and fuel cell? As I told you, the biggest difference between the two is that a battery stores energy while a fuel cell generates energy by converting the available fuel, that is hydrogen. A fuel cell can have a battery as a system component to store the electricity it's generating. That means along with the fuel cell, you can take the battery also. If the excess power is there, that is also can be stored in the battery. Unlike a generator, a fuel cell directly converts an energy source into electricity through a chemical reaction. One step rather than the multiple steps. This allows a fuel cell to remain efficient, quiet, and clean. Since a fuel cell converts a fuel's chemical energy rather than the combusts the fuel the way a generator does, the result is a fuel cell that can create clean electricity efficiently and effectively if we compare with the generator. This is a comparison of so many factors with respect to different storage systems like the batteries, supercapacitor, and flywheel. Let us come to the microgrid system. As all of us know, it is a small scale power supply network that is designed to provide power for a small community, like at the residential purpose or at the market complex, or we can think of a for a village also, or at a particular institute or industry. Then this is the microgrid. It is a small capacity up to megawatt range, you can say. It enables local power generation for the local loads. Means we are generating the power at the load side. It comprises of various small power generating sources like the PV, wind, battery, supercapacitors, and fuel cell that makes it highly flexible and efficient because the control is at your hand and locally the information is available so that the control will be more easy. It is connected to both the local generating units and the utility grid, thus preventing the power outages. Excess power can be sold to the utility grid. As I told you, will not be the only passive consumers. In future, smart grid will become the prosumers instead of the consumers. Size of the microgrid may range from the housing estate to the municipal regions. This is a example of a microgrid system, you can connect with the utility grid by means of the bidirectional switch, static switch, or you can operate under the standalone mode also. This is with the different sources as well as storage. Yeah, as I told you, there is a bypass switch, which is a static switch. If the switch is on, then you can connect the microgrid with the utility grid. If the switch is off, that means your utility grid is isolated from the microgrid. And there are different sources, storage, electric vehicles. You can have the subsections kind of thing. Like you can think of one DC microgrid, you can have the one AC microgrid, you can combine also to a particular bus by means of inverters or converters. As we told that these are the examples of the microgrid system where the power can be generated for the residential purpose, data center, campus. What are the benefits of the microgrid? It provides efficient, low cost, clean energy. That is the main advantage. Improve the stability of the regional electric grid, and it uses the energy sources which is locally available or available in the nature. It offers grid service, energy capacity, and ancillary services. Because of this microgrid system or the huge penetration of the renewable sources, you can enhance the grid resilience also. There are different types of the microgrids. One is AC microgrid, where you can generate the power from the all the sources like the PV, wind, but particularly your common bus is the AC bus where the loads are connected. And in case of DC microgrid, your common bus will be DC bus with a particular nominal voltage, and you can connect the both DC loads directly to the DC bus, and AC loads you have to use the some converters again. Then you can use the AC loads. And in some applications, you will find the hybrid AC-DC microgrid so that directly the AC loads will be connected to AC common bus and DC loads will be connected to DC common bus. So that no need of again the converters. But the control mechanism, it will be more complex in case of a hybrid AC-DC microgrid system. There are few practical challenges, as we have already told you, that is renewable energy sources are intermittent in nature, and for which you cannot depend only on the solar or wind. You have to go for the energy storage system, and which requires the maintenance also, and the cost will be also comparatively high, and space is also required when we talk about the energy storage systems. And you have to forecast the load demand, and accordingly you can schedule the power generation, means how much power will be generated from the PV source, how much from the fuel cell or the combination. All those things you have to make the scheduling of the power generation. And when you operate the microgrid under standalone mode, you have to maintain the voltage and frequency at a nominal value or at the reference value. And there may be a chance of fault or there will be a voltage sag, swell, anything may happen in the microgrid system, and you should have the detection technique, accurate detection technique, accurate as well as the fast detection technique. This one we told you that we can operate the microgrid in grid connected mode as well as in isolated mode. And that also I told you, when the switch is on, it is a grid connected mode. And when the switch is off or your grid is isolated. And depending on the mode of operation, your control strategy will be also different. Due to the grid failure, intentional disconnection and other causes, system will shift from the grid connected mode to islanded mode. And for that operation, means if you want to operate in the seamless transition mode means if you want to operate the microgrid in both grid connected as well as in islanded mode, or the reverse is also possible. Let the system is in islanded mode and immediately you want to bring to the grid connected mode. That is called the seamless transition of the microgrid system. And when we talk about the seamless transition, you have to focus mainly on the few aspects. One is the fast islanding detection scheme. It should be available. And secondly, there will be a transfer of the control schemes. Transfer switch will be there, where the current control mode to voltage control mode or voltage control mode to current control mode. And grid synchronization. And power management strategy will be also different for a grid connected mode as well as a islanded mode. This one you can find that one of our published work, that is using the PV and battery, how it is operated in both the modes, like the seamless transition of the microgrid system. When you operate in grid connected mode, the grid maintains the voltage and frequency, nominal voltage and frequency at the PCC. Only you have to push the power available. What is the power available at the PV side? Your main objective to push the power towards the load side. Okay, and it is used as a PQ control mode. Under grid connected mode, you can go for the active and reactive power control mode. As much possible, you just push the power towards the load side. And that time, this will be acting as a current control mode. Which one? The inverter. But in case of islanded mode or standalone mode, as all of us know, the loads are rated at the nominal voltage and frequency. It is our primary duty to maintain the PCC voltage and frequency at the desired values. That's why it will jump from the current control mode to voltage control mode. Okay. Your inverter control scheme will be different here. Here we can see, in case of grid connected mode, the output voltage and frequency of the microgrid are primarily detected by the utility grid. The inverters act as a current control source to feed the available power. The inverter should maintain the DC link voltage at the nominal value for a stable operation of a DG system. In case of islanded mode, the inverters act as a voltage control source to maintain the DG system voltage profile. The controller of the DG inverter should have the control over the current dynamics. The controller uses voltage compensators to generate the current reference for the current regulation. What is islanding? Islanding is the situation in which a distribution system becomes electrically isolated from the power system, yet continues to be energized by the PV connected to it. You can see from this figure, this DER means you can think of as a PV source or wind, and it is providing the power, though it is isolated from the main power system. Because of this circuit breaker is disconnected due to some fault condition, this is isolated, but still it is energized because of the available source, that is PV. There are two types of the islanding. One is intentional islanding, another is unintentional islanding. Intentional islanding means it is a planned kind of thing. Let you have to make the intentional islanding for some kind of maintenance. And unintentional, there may be a fault occurs in the system. Due to that, you can go for the unintentional islanding. There are different issues with unintentional islanding. Personal safety, because though it is one part is isolated from the mains power system, but still that is in energized mode because of the PV or renewable energy source. Over voltages, reconnection out of phase, power quality also will be hampered. And there is a protection issue. Unintentional island may not provide sufficient fault current to operate the fuse or overcurrent relay protection devices inside island. Fault current may not be sufficient. That's why you have to use the different accurate and fast detection schemes. And like you can think of the wavelet plus ANN. You can think of so many algorithms, very much accurate algorithm, one of the research area in islanding detection, fast islanding detection in microgrid systems. And particularly this is classified into three categories. One is passive methods, another is active methods, and if you go for the combination of these two, you will get the hybrid methods. Fast Fourier also you can use for the detection schemes. Yeah, those are the challenges or the issues, technical challenges and issues in the microgrid. But there is still opportunity also there for this microgrid. What may be the opportunity? Here we can see hydrogen from the curtailed energy, a business opportunity in India. We have taken one, means these are the points from one literature where the business opportunity is also possible. And so much statistical data was given, but I have not taken that thing, means how the cost, all those profit will be there. Idea is here, the curtailment of renewable power is an observed phenomena in renewable rich states of India still. That means in few states where the renewable energy is available plentifully or the rich state kind of thing. But our requirement is not there. That means we are not reducing the conventional power as as it is already available the conventional power. And what is the minimum requirement? We are going for the power generation from renewable sources. That means additional available renewable source that can be used for producing the hydrogen. Okay. That can be used for the producing the hydrogen. In many cases, limitations in backing down of the state thermal generators to accommodate renewable generation, forcing the system operate to curtail the power from the renewable energy sources. Under present scenario, RE curtailment in few states of India are estimated to be around 50%. You see, this is the statistical data from the literature. This is resulting loss of revenues for the developers and sending the negative signal to RE investment. The curtailed energy needs to be utilized commercially for sustaining the growth of the renewable energy sector in India. Converting cheap curtailed energy to green hydrogen at a comparable market rate can be a business opportunity supporting simultaneous growth of RE and green energy sector. Coming to the next part is the smart grid is the modernized electrical grid that integrates advanced sensing, communication and control functionality for the purpose of enhanced efficiency, reliability and security in the operation of the utility grid. We all know what is grid. The grid refers to the electric grid, a network of transmission lines, substations, transformers, and more that deliver electricity from the power plant to your home or business. What makes a grid smart then? In short, the digital technology that allows for two-way communication between the utility and its customers and the sensing along the transmission lines is what makes the grid smart. That means when you will integrate ICT into the grid, it will become the smart grid. With the promises of the smart grids, power can be more efficiently and reliably generated, transmitted, and consumed over conventional electricity systems. Though the two-way flow of information between the suppliers and consumers, the grids can also adapt more readily to the increased penetration of the renewable energy sources and encourage users' participation in energy saving and cooperation through the demand response mechanism. Yes, as we told you that if we'll integrate the ICT with the grid system, it will become the smart grid. Smart grid is the modernized electric grid that integrates advanced sensing, communication, and control. We have already discussed this thing. And these are the smart grid characteristics. It enables informed participation by the customers. It accommodates all generation and storage options. It may be a small micro source also. Everything will be into network. Enabled new products, services, and market. It is a huge scope for creating a market. provides the power quality for the range of needs. It optimizes asset utilization and operating efficiency. It is only possible because of flow of information. Here you see that there are different components of the smart grid. These are the important components like the distributed energy resources, distribution automation, and very important component, that is PMU. We must be knowing, that is phasor measurement unit, which provides accurate information about the magnitude, phasor, voltage, frequency, everything in a very accurate manner. That's why the synchro phasor measurements units, if you are using, you will get the all the information correctly. The integrated communication platform for these components will be the main area of focus instead of individual components. That means you have to integrate all the components so that it should have the all the information at the control unit, so that the decision can be taken accordingly. Yeah, what are the technical challenges in smart grids? Interoperability, network communication, demand response, energy storage, distribution grid management. Interoperability, that means the information is required. The capability of two or more networks, systems, devices, applications, and components to exchange and readily use the information securely, effectively, and with a little of no inconvenience to the use. That means the information flow should be more reliable. Smart grid network communication. This The smart grid domains and the subdomains will use a variety of public and private communication network. It may be wired network, it may be wireless network. This variety of networking environment is critical to identify performance matrices, validate core operational requirements of different applications, users, and domains, maintain appropriate security and access control. Another important aspect is the smart grid demand response. Demand response mechanism. You'll find very good research articles how you can go for the demand response mechanism and incentive characterize basic smart grid objective for utilities, business, industrial, and residential customers to cut energy used during times of peak demand, be efficient when the power reliability is at risk. That means you should have the own storage device or own system so that you should not be depend on the power from the main grid. That means it should be efficient when the power reliability is at risk. And you should manage your loads in such a way that you connect lesser load during the peak hours, and which are the important loads that you use during the peak hours, and during off peak hours you can use the maximum loads. And also it is important to optimize the balance between the power supply and load demand. there are different opportunities also available in case of smart grid. They are the basic research and development and fundamental technology that will move the smart grid forward. Integrated communications to connect the components to open architecture or drive real-time information and control, allowing every part of the grid to both talk and listen at the same time. Okay. Means the information should be very fast and accordingly the decision should be taken. Sensing and measurement technology to support faster and more accurate responses such as remote monitoring, time of use pricing, that is dynamic pricing, and demand side management. Lot of things are at the research level and pilot projects are coming. Let us think of it when we can see this smart grid into the reality. Advanced components to apply the latest research in the superconductivity, storage, power electronics, and diagnostics. Advanced control methods to monitor essential components that enable rapid diagnostics and precise solution appropriate for any event. These are the features of the smart grid that we will not be discussing here. We will go to the next part, which is our important part, that is the power management and control in the DCAC microgrid system. As I told you, there are three different types of control. One is active and reactive power control. Next one is voltage frequency control and droop control. That active and reactive power control generally used for the grid connected microgrid system. Voltage frequency control is mainly used for the standalone system or isolated system, and droop control is this concept is used for maintaining the active and reactive power. Active power control related to the frequency control that all of us know. Reactive power control, it is relating to the voltage control. And as I told you in the previous slide, that it is mainly used for the grid connected mode operation. In this system, grid maintains the voltage and frequency, whereas the maximum power available at the source side, it will be pushed towards the load. Voltage or frequency control to maintain the rated voltage and frequency of the system irrespective of active and reactive power outputs of the sources. A frequency controller adjusts the active power output to maintain the frequency at reference value. A voltage controller regulates the reactive power output to maintain the voltage at the reference. Droop control. A droop control scheme uses only local power to detect changes in the system and adjust the operating points of the generators accordingly. In this case, it will be the inverters. In the microgrid, the load keeps changing all the time. So the generators will change their output based on the frequency deviation. With these characteristics, you will see the active power versus frequency and reactive power versus voltage. You can see what will be the operating point if the frequency changes or voltage changes. Let us consider one DC microgrid with different sources and storage device. Here you can see, as I told you, in case of a DC microgrid, the common bus is your DC bus, and our main objective is to maintain that DC bus voltage at a particular value under the different operating scenarios. Under different operating scenarios means maybe the load is a variable one, maybe the your intensity of light or irradiance level is different for the PV. As much possible, all the operating conditions you can take, and you use the control scheme as well as the power management scheme together and maintain the constant voltage at the DC bus. Here you see we have taken a small example, and this is only fuel cell based DC system. If any of you wants to start your research work, you can think of in that line, means how the small things are used and how it is simulated and how you can test it. Let you don't have the hardware system, but you have the FPGA board, you can go for HIL simulation, so that your controller, what you have designed in the simulation platform, whether that is working fine or not, you can test it using the FPGA board. And particularly this is called the HIL simulation. You can vary the different loading conditions using this fuel cell stack. You can maintain the voltage by means of the control scheme. Because here the power circuit, that upper part of the circuit will be in the MATLAB Simulink, whereas the lower part will be in the lower part means the control scheme you can develop in the FPGA board. This is the work done by one of our MTech scholar long back. Here you see that this is the Xilinx modeling of the fuel cell based DC system. Means what the in the Simulink you have developed the control blocks that should be modeled in Xilinx. Similarly, you can go on increasing the fuel cell plus supercapacitor together based the DC system. And accordingly, you can test your control scheme with the different loading conditions, whether the voltage is maintained or not. This is the Xilinx modeling. Here you can see that how the fuel cell and supercapacitor together maintaining the load demand. Okay, you can take the different loading conditions. At the beginning, it was constant value, then it becomes 0. Like that, you can increase or decrease the load conditions and how the operation takes place. At what point of time the fuel cell provides the power, at what point of time supercapacitor provides the power. Here the combination of PV, fuel cell and a supercapacitor. When this MTech student starts his thesis work, he started from the basic level. Then slowly during his work, he published one IEEE paper. This is the paper. Okay. Here he has used the power management and the control. Means how the SOC limits can be maintained. SOC limits means minimum SOC and maximum SOC for both supercapacitor and battery can be maintained, and by using this algorithm, and at the same time under different loading conditions you have to maintain the voltage also. We have given only very few results. This paper is available in the IEEE Industry Informatics. Under different loading conditions, we have checked how the combinations means at what point of time the supercapacitor is coming and providing the power, and when the fuel cell will provide the power, or combination of together, so that aim is to meet the load demand. Yeah, coming to this energy management scheme in the smart grid. Smart grids are electricity grids that use information and communication technology from the points of generation to the customers in a smart way as an integral part of the smart grid. Since they can contribute to the balance automatically between the generation, consumption, and distribution. The integration of a highly fluctuated distributed generation such as PV, wind turbines, electric vehicles, and energy storage systems threatens the stability of the power and distribution system. The main cause is the how to maintain the balance between the supply and demand. An excess shortage or either excess or shortage in the generation or consumption of the power may perturb the network and create the severe problems such as voltage drop or rise. If the imbalance is there between the generation and demand, automatically there will be a voltage drop or rise, and in severe conditions blackouts may occur. To increase the balance between the supply and the demand in an efficient way and to reduce the peak load, as we told you, during the unexpected periods, energy management system are utilized. Okay. During the peak hours, means this demand response or demand side management is very much important. An energy management system is a system of computer aided tools used by operators of electric grids to monitor, control, and optimize the performance of the generation and transmission system. What are the objectives of the energy management? The main goal of using energy management is to reduce the cost of operation and consumption, reduce the energy loss, and increase the reliability of the network. That means we have to optimize the operational cost. Energy management can be divided into two main categories. One is supply side management. It is on the side of the supplier, such as electric utility, in which some generators are turned on or off to follow the fluctuation of the load demand. Another is the demand side management. It is on the consumer side and it is called the demand side management. In demand side management, the consumers manage their energy consumption in order to meet the available power from the generation side. What is generation side available power? Looking to that, the consumers has to think which of the loads to be connected so that the balance will be maintained. Let us take one microgrid system with the different sources and storage and how it behaves. Because there are few constraints also. There will be some few constraints. You have to think also that thing. The objective of the energy management system is to supply the demand load from the DGs, ESS, and the utility grid with respect to the optimal economic technique to maintain the or to minimize the operational cost. That means our main objective is to minimize the operational cost and with the different constraints. You have to go for the PV modeling, with modeling. We'll see here how it is used. Yeah, this is the cost function, objective function. Okay, this is important for any hybrid system. You have to minimize this cost. This cost means this is a operational cost. It should be minimized. Here you can see that CPV, CWG, CESS, all are the operational and maintenance cost of the output power of PV, wind power, energy storage system. And whereas the CGB and CGS are the cost of purchasing or selling power from or to the utility at the hour T. These are the cost factors, and taking that you have to make a objective function model, and using any algorithm, optimization algorithm, you have to optimize or minimize this cost. But these are the constraints. One is there should be power balance between the generation and the load demand. That is one equation. Then what are the constraints? Source constraint: to keep the system stable, the DG output power must be within the suitable limits. Also, there are many constraints that must be taken into consideration to maintain the lifetime of the battery and prevent its damage. There is a limit on the amount of energy stored in the battery. That is the SOC limit, SOC minimum and SOC maximum. The input output power of the batteries is limited also by the maximum charging or discharging power. These are the constraints: PB minimum, PV power maximum. Similarly, the wind power minimum and wind power maximum, and SOC minimum and SOC maximum. These are the constraints you have to take into account. And using any optimization algorithm, you can minimize the cost. Accordingly, you can make the scheduling of the power generation. This is one of our published work using the power management and control scheme in both grid connected and islanded mode, how the power quality is maintained. As I told you at the beginning that one of our published work, how you can use a accurate islanding detection scheme and control, that is the robust control scheme, so that to operate the microgrid in a seamless transition mode. These are the few results, both simulation as well as hardware, that you can, those who are interested, they can see our papers also. Particularly, we have published in a power management and control for a seamless operation of microgrid. Similarly, we have published few papers also in power quality improvement using the active power filters. And you will find few good papers in multi-level inverters also. These are the references of ours. It is available in our Google Scholar. You can see. Those who are interested, you can refer our paper. Particularly, as I told you at the beginning, I will be discussing very basic parts, means where the research opportunity is there, and how the system works, what is microgrid, and what is the smart grid, where the In a smart grid now you'll find very important research paper that security issues like the cyber security. Okay, if many of papers you will find, if you'll think of the combination of computer science faculty and electrical faculty, they are working on this cyber security issues, how the how it can be detected as well as protected cyber attacks in the smart grid. That is very important research work. And the few research fields you can see that where the demand side response with the electric vehicle coordinated charging station, how the your grid resilience can be improved. And I have already discussed about the robust control and power management for a simulation of operation of microgrid system. This is all about my presentation. Now I can interact with the participants if you have any queries. Yes, if you have no query, I'm happy.
Thank you so much, sir.
Yeah.
It is actually an informative session for all the participants. And
You have good number of participants, right?
yes, sir.
How many participants registered? Around registered participants are around 200.
Sir, it's 68, sir.
Okay, good. Okay, now I can leave.
No, sir. If the participants, if you have any queries, or we'll move further for the next session. Okay, sir. It's fine. Sir, from our side, from Dreams Autonomous, we just give you a token of respect and appreciation to give your time for this particular technical session. We just want to share you with the e-felicitation process from our side.
Oh,
So, Swaroop,
felicitation process is there.
yes.
Good.
So as this
Yes,
is
Yeah,
the
yeah.
virtual mode.
Yes. And congratulations, you become the HOD, I hope.
Yes, sir. Thank you, sir.
Good. Yeah, Dr. Pratap
Sir, namaskar.
is there. He is the main coordinator, I think, of this program.
Yes, sir. Yes, sir.
Yeah. Okay.
Sir, so this is from our side, from Dreams Autonomous,
Good.
as you
Thank
have
you.
given
Thank you.
your valuable time for us and for the participants as well. So it's a token of respect and appreciation from our side. So do accept it,
Good.
sir.
Sure. Accepted.
Thank
Thank you, all of you, and wish you a very, very happy New Year again, and
Thank you so much,
great
sir.
day for all
Happy,
of you. Okay.
happy New Year, sir.
Thank you, sir.
Yeah.
Thank you so much, sir.
Now I can leave, I hope.
Yeah.
Yes,
sir.
sir. Yes, sir. Yes, it would work.
Thank you very
so
much, sir.
Thank you.
So it's an information to the participants. We'll again, so you just stay connected for the next session. We'll sit again at 11:45 for the next session. And this is for the bio break. If you, it would be better if you'll stay connected with this link as well. So thank you for have a good day, and we will join at 11:45 again. Thank you.